4 different people, apparently. Yeah, dumb. If they don't watch it, they're going to take away lunch completely.
Are you for real?
Yeah. Like, you'll get lunch and have to go inside back to 5th period, yeah.
No.
Tell people to stop doing... The reason we went to one lunch is because there's less kids, so we could have one lunch. Oh, Miss Huber. Because we have less kids, and so we thought if we only do one lunch, it's easier to do activities at lunch or things like that. We used to have 2 lunches, but we also had 3,600 students. We only have 1,800 and some odd students, and so there's only one lunch. So we should not. I hate 2 lunches. I hate 2 lunches. How does it work? 1, 2, 3 lunch, or 1, 2, 3, 4 lunch. Yeah. So your 4th period will determine. Yep. And then it switches, and then they're still in 4th period. You go to 4th period and start, and then halfway in, roughly, they go to lunch, and you still in 4th period. And then you all go to 5th period at the same time. It's the worst. Like, it really is. Because some teachers eat, like, at 11 o'clock. Some teachers will eat, like, at 12 o'clock. Some people, like, it just depends on what it is. Right. And then you can't do presentations. You can't do group meetings. You can't do any of those things. Yes, and then actually what happens is off-campus becomes, more people start being not very smart, and they start going to 2 lunches, and then they get in trouble for that too, and lose off-campus and all that fun stuff. So, it's actually worse. Yeah. They're probably barely coming on campus right now. It's very annoying. Because I still need to, yeah. I just finished eating. God bless you. I really will be switching seats probably come Monday. I'll probably do it this weekend. I was going to. I had to put grades in. I already sent them in, yeah. Today. So I could do the cutoff today. And I'm not changing them. I like entered homework, but it's not gonna. All right, ready? Example time. Ready to write without looking? Let's practice. Here you go. Without looking up here. Yeah. All right, here we go. It says a bicycle shop sells about 18 bikes per week. When it charges $100 per bike. For each increase of $10, the shop estimates that it will sell 3 less bikes per week. We're not done. If the shop is trying to maximize its profits, how much should the store charge per bike? Now we're done. Crap. How many of you did it all? Good. Yes. Yes. It didn't work yesterday on my class. They came by, and then today when they did it, it worked. So what they did was they just checked it, pulled it, and like tried to open. And yesterday it opened, and today they checked it, and I didn't even know they were there.
Oh, this teacher said it, like, she said that if somebody shoots the little window and presses the button, could they come inside? So, like, inside? Can you open it from here?
I don't know if you're allowed to open it at all. It's not really a window though. It's like plexiglass. Yeah. Yeah, it's pretty. So. We're supposed to. Okay, let's talk about this really quick. Here we go. So, let's go ahead and underline. I'm going to use 2 different colors to highlight. So if you're highlighting, you probably want 2 colors. If you're underlining, just get 2 colors. If you have 2 colors. Can you tell the difference? Oh. Kinda. Yeah, because one of them shows up like the same. I'll use yellow, I guess. Okay. Here we go. What's up? Yeah, over here. There's a whole bag. Just grab a bag. So right over here, there's a whole bucket, and just grab a bag of highlighters. See it? There you go. Take them all with you. There should be 4. Yeah. Mm-hmm. You're welcome. All right, so let's underline keywords. Here we go. I'm going to use 2 different colors because we're talking about 2 different things. So it says a bicycle shop sells about 18 bikes per week. What's important in that sentence? Why are we still talking? 18 bikes a week. When it charges $100 per bike, what's important there? $100. Now let's pay attention. 18 bikes was yellow because it was talking about what? The amount of bikes, right? So when I'm talking dollars, should it be the same color or a different color? It should be a different color. So 100 per bike is a different color. All right, let's keep reading. For each increase of $10, the shop estimates that it will sell 3 less bikes per week. What do we need in there? Increase of $10. What color? The pink color. Increase means what? We're going to go up. So we're probably adding. The shop estimates that it will sell 3 less bikes per week. The yellow is 3. Less means what? Subtraction. And bikes per week. Okay? It the store is trying to maximize its profits, how much should the store charge per bike? So at the end, it wants to know, we want to make the most money. Do you understand? So we want to make the most money. We don't want to charge you, like, let's just say we're selling nachos, right? We're selling nachos at $5 an item. Do you think we're going to sell a lot of nachos? No, we're not. We're not the baseball stadium or the football stadium where we can charge a lot. So, or $20 helmet, not, you know what I mean? Yeah. So we're not going to charge a whole lot at like our football games, right? But we're not going to charge $1 for nachos because are we really making money off the $1 in nachos? Probably not. We're probably making like 25 cents, and if we charge $2, we're probably making a little bit more, right? So we're going to maximize our profit. What are people still willing to pay, but without going crazy? Does that make sense? So that's how we figured that out. So here, we're trying to figure out the same thing. We're seeing what's happening, though, to our problem. So I want you to pay attention really quick. So you're not going to write, you're just going to pay attention for this part. It says, X is going to represent how many, right? Does that make sense? Now, weekly revenue. What does weekly revenue mean? How much you're making or earn per week. Why are we worried about weekly? Because it's selling per week, right? How many bikes per week? So we're talking about the week. So we're trying to figure out how much are we really making in the week. Well, our weekly revenue is equal to the number of bikes sold, right? Times what? How do you figure out how much you're making? That's number of bikes sold times the price of the bike, right? Okay, makes sense? Okay. Now, we are trying to write a function. Now, I'm going to help you write this function. I want you to pay attention to it. R just stands for revenue. Okay. X stands for my variable. Now, let's pay attention. We started with 18 bikes per week. The yellow is going to go together, right? So just watch for right now. We said 18 bikes per week. Yeah? 3 less bikes per week. Minus 3 what? X. Very good. Does that make sense? Okay? So that was that color. Then the other color was this lovely purple. And it says it was $100 per bike, and then we increase of $10. So 100 plus 10x. Very good. Because the $10 is for every what? For every bike. Does that make sense? Okay. We good so far? Do you understand how this is talking about quantity? Not money. It's talking about quantity. How many bikes are we selling? This is talking about money. What's the price we're getting? Do you see how they go separate? Do you see why I color-coded them separately? Okay, so that's what I did first. Are we good? Now I'm going to rewrite this to look a little different because I don't like the x at the end. So I'm going to rewrite it to say r of x equals negative 3x plus 18 times 10x plus 100. We good there? Okay. And you can still watch for right now because I'm going to do a lot to this problem. Then I'm going to ask you to take out a GCF. So what is the GCF of negative 3 and 18? Negative 3. Why negative? Because you want your x to be positive. So that becomes x what? Plus 18 or minus or what? Minus 6. And what's the GCF of 10 and 100? It's 10. And what do we get next? X plus 10. We good? Okay. Nothing weird's happening. Then I'm just going to say, hey, let's put that negative 3 and the 10 in the front. And I don't know why you're talking over there. So I'm going to go ahead and put that negative 3 in the front along with that 10 because it's kind of weird just in the middle. And then we have x minus 6 and x plus 10, right? All I did was rewrite it. And then I could say to myself, well, I don't really like negative 3 and 10 just there, so I should probably multiply those two to give me what? Negative 30. So I get negative 30 times x minus 6 times x plus 10. Does that make sense? Okay. So now, I'm looking at this and I'm like, okay, there's my function. It's a little prettier now. Okay. What form is that? Standard, intercept, or vertex? Intercept. It's an intercept form, right? So if it's an intercept form, then I can find the what? The x-intercept. So let's do that. How do I find x-intercepts? Equal to 0. So I'm going to let you guys catch up for a second before I do x-intercepts. All right, we okay? We good? Ready? Okay. So, I'm finding where these x-intercepts are. Well, first of all, to maximize profit. Profit is special. It's a parabola, right? To maximize means you have what? A parabola going up or parabola going down? It's going down. Because maximizing means it's your highest point. Good. So this is where you maximize the profits. Maximize. Yes? Maximize. I feel like I spelled it wrong, but I did. But it's okay, whatever. We maximize the profit up here at our vertex. Make sense? Okay. So we're way up here. But in order to get there, we have this lovely form that helps us find our x-intercepts. Right? So let's go ahead and find our x-intercepts by making it what? Equal to 0. So 0 equals negative 30 times x minus 6 times x plus 10. Then what do we do? Yes. What do you do with negative 30? You what? We got to move it. You can't just keep it there. You divide. But it really doesn't change my problem a whole lot, correct? Okay. Then what do I do? Two separate equations. Plus, remember, we want to graph this eventually, right? In order to graph it, I need x-intercepts, I need a vertex, all of that fun stuff. So we get x minus 6 equals 0, and x plus 10 equals 0. And then what do I get here? X equals what? Ordered pair. Good. And x equals what? Negative 10, so ordered pair. Good. All right, so in order to graph, I need x-intercepts. I found them. I also need what? A vertex. How do I find the vertex? How do you find the axis of symmetry, though, when you're in what intercept form? P plus Q divided by 2. Why is it divided by 2? Why is it divided by 2? What are your x-intercepts? They're what? Aren't they equally as far away from the vertex? So that's why you divide by 2 to find where the middle is. So what's P? 6. And Q, negative 10. So we're going to do P plus Q over 2. So we say 6 plus negative 10 over 2, which is what? Negative 4 over 2, which is negative 2. Okay, we're good so far. Got to find the rest of our vertex. Because remember, we're trying to find money. We're going to plug it in. Now pay attention, though. We're talking about profits, right? We're not talking about how many bikes we sold. We're talking about what's our maximum profit. How do we find maximum profit? So when I'm looking here, I'm looking at it, and only part of this was profit. What part? The second part. The second part talked about money. Is it money profit? So I'm going to take this part here, only this part here, and I'm going to solve that part. So I'm going to plug in negative 2 there. So I'm going to plug in 100 plus 10 times negative 2. Now this is not finding my vertex. Do you hear me? The second part is not, this is not the vertex part. The second part here is just to find the maximum profit. Okay? To actually graph it, it's a little different, but we're going to find it here. So then we're going to go ahead and plug it in, and we're going to get 100 minus what? So how much is it? $80. So how much should I be selling bikes for? Yeah. So the bike shop should sell the bikes for $80. If I sell it for $80, will I sell more bikes? Yeah. So in the long run, do I make more money? Yeah. Okay. We're not going to graph this one. We're going to do the next one. Ready? Ready to write? My hand hurts from writing. Yeah, right. I have another 2 pages. Let's go. Well, this example is here and there. Ready? Here we go. An object is launched upward with an initial velocity of 64 feet per second from a platform 80 feet high. Impressive. Only about 4 of you have to look up, 5 of you. Okay? That's our problem. Now we're going to write all 4 things it's asking. Number 1. Write and graph a function that models the height of the object. Write and graph a function that models the height of the object. Number 2. I'm going to just solve it all underneath and then come back to it. How many seconds until the maximum height is reached? Number 3. What will the maximum height be? Number 4. How many seconds until the object hits the ground? Sorry guys, I was sleepy. Alright. Highlight keywords in the very top. In the very, very top. Not in the 4 parts, but up here at the top. An object is launched upward with an initial velocity of 64 feet per second from a platform 80 feet high. What do we underline? Say it again. Launched upward. What else? That's what it's talking about. With what? Initial velocity. Initial is important, guys. Initial velocity of what? 64 feet per second. From a platform where? 80 feet high. I'm going to underline feet per second only because that's my measurement, not because it's like I'm going to use it really, but it's my measurement. Okay? Oopsies. Oh my goodness gracious. All right, let's talk. I'm going to move it up because some people need to see. Now, there's a formula. I didn't come up with this, guys. It's talking about velocity. It's h of t equals negative 16 t squared plus v naught t plus h naught. H naught. V naught and H naught are, 0 represents what? What do you think 0 represents? It's your starting spots, okay? V naught is your velocity. It's your initial velocity. H naught is your initial height. Okay, so we're ready? Ready? We're going to take what we know at the top and plug it into this formula. Are we plugging anything into negative 16t squared? No. Are we plugging into v naught? What is v naught? 64. So I'm going to write this as h of t equals negative 16t squared plus 64t plus, what's my initial height? 80 feet. Why is it 80? Because that's the platform I'm standing on. So here's a sketch. We're going to go sketch it on the side. Here's this platform, right? We know it's 80 feet up. Here's this person. What are they doing? Launching something. We don't know what it is. It could be anything. It could be a firework. It could be a ball. And then it's coming where? Back down, right? I may have drawn it a little bit too far. What does this represent? The ground. Now, if this is representative of the ground, what is this point right here? Direct intercept, but what does it mean? Where it hits the ground. So, isn't there a question that asks for that? Which question is that? Number 4. Number 4 says, how many seconds till the object hits the ground? Well, if it hits the ground, that means it's your x-intercept. So I'm going to go write that over there so I know that's what I'm looking for there. Sorry. It also says, how many seconds until the ball reaches it, or whatever it is, reaches its maximum height? What does it mean to be maximum height? The highest point. What's the highest point of this parabola? The top, which is called the vertex. Maximum points. Yeah? Questions? It's nap time. We good? Okay. So what are we going to do? We have our function. What do you want to do with it? Oh, wait, I forgot to write it over here, sorry. Maximum height, we said was what? The vertex. So, vertex over there. Okay, what do you want to do? We can find x-intercepts. What else do we need to do? Find the vertex. What do you want to do first? Vertex? Okay. Let's do vertex. How do you find the vertex? Axis symmetry, which is what? What is it? Why is it negative b over 2a, not p plus q? It's in standard form, not in intercept form. So let's do x equals negative b over 2a. Now, really quick, x isn't really x, it's what? T. So x is time. What are we measuring time in? Seconds. And what is y represented of? Height, which is what? In what? What are we measuring it in? Feet. Very good. You should probably know that, okay? It's going to help me answer the questions. Okay, so negative b over 2a. So negative times something over 2 times something. What's your b? What's your a? Sorry, guys. Oh, my gosh. Multiply, you get negative 64 over what? Negative 32. To what? It's positive 2. What does 2 mean? To what? 2 seconds. At the 2-second mark, it's at the top. Now at the 3-second mark, or 2.1 second mark, it's doing what? It's coming down, right? So right now at the 2 seconds, 2 exactly, it's at the top. Anything after 2, 2.01, 2.0001, like anything after, it's coming down. Make sense? So at the 2 seconds, it's at the top. Did I just answer one of my questions? Which question was that? Number 2. Number 2 said how many seconds until the maximum height is reached? You can say it's what? 2 seconds. So go answer that at the top. Okay? So we're back down here. We found it's 2 seconds at the top. What else do we care about? The other part of the point. The other part of the point is going to tell me what? How high. So remember, we started at how many feet? 80. So my answer should be greater than 80 or less than 80? Greater than. It should be less than. It should be greater than. Because it's 2 seconds, we threw it up, and then it's going to end up coming down. So what do we do to 2? Plug it in. For which variable? For t. Okay. H of 2 equals what? I should have skipped a line. H of 2 equals negative 16 times 2 squared plus 64 times 2 plus 80. What do we do first? Exponent. So 2 squared is what? 4. 4 times negative 16. Negative 64. Plus 64 times 2. 128. Plus 80. I'm so sorry. Me neither. Negative 64 plus 128 is how much? 64 plus 80 is how much? Very good. 144 what? Feet. Did I just answer another question? Yeah, what question did I just answer? What will the maximum height be? Number 3. 144 what? Feet. So if I look into question 1, it said write and graph a function. Did I write the function? Yeah, I did. It's right here. So I wrote the function, but I haven't graphed it. But I can't graph it until I do all the other work, right? Otherwise, I just have this random function and I don't know how to graph it. Now, it says how many seconds until the object hits the ground. And we wrote to find the what? The x-intercepts. How do we find the x-intercepts of this function? Starts with an F. You got a factor. Oh my gosh. Didn't you have a problem like that yesterday in your homework, number 1? Oh, okay. I'm going to factor on the next page because I'm also going to graph on the next page. All right, what's the first thing you ask yourself? Is there anything in common? Negative 16 is in common. Why negative? Because t squared has to be positive. And 16 divides into all of them, so that works. So we factor out a negative 16. What do we get when we divide by negative 16? T squared minus 4 t minus 5. Very good. Okay, now what do I do? Factor. Oh my gosh. Goodness gracious, people. What goes on? I know, I'm sorry. I can't stop. What goes on top of your x? Negative 5 and on the bottom. And on the sides. 1 and negative 5. Very good. What does t squared and 1t have in common? T. Negative 5t and negative 5? T plus 1, t minus 5, equaling to what? 0. I kind of dropped the negative 16 though, right? So what should I do with that negative 16? Divide it out. So t plus 1 and t minus 5 equals 0. Now what do I do? Two what? Two equations. T plus 1 is 0. T minus 5 is 0. So what is t? Negative 1 comma 0, good. 5 comma 0. Now what do we have to do? Gotta graph it. The x-axis actually represents which letter? T or H? T. And the y represents H. All right, I'm going to count the x-axis by 1s, and I'm going to count the y-axis by 20. You okay with that? Why would I do 20? Good, because the starting height's 80. If the starting height's 80, I don't really want to count by 1s, just so you know. I could count by 5s, but I still have to have a lot. 10s work too, but my graph is kind of small. So if you said the starting point's 80, what does that mean? That's the height, the y-intercept, because your time is what? What's time right now? If you're sitting here, what's your time? 0, because you haven't done what? You haven't launched it, right? Just sitting there. Okay, so there's my starting point. Where's my vertex? 2 comma 144. What's your x-intercept? Negative 1, 0, and 5, 0. Which one actually answers my question, though? 5, 0. Why does negative 1 not answer my question? It's asking when it hits the ground, and t represents what? Time. And if you have negative 1 second, that doesn't really work, right? So this isn't really an x-axis. It's kind of just there. We can kind of put a point, but my graph isn't really starting there, correct? Does that make sense? So do you understand why we only have a partial graph? I kind of drew the point, but I'm not going to connect it because it doesn't really mean much, right? Because you can't have negative 1 second. If you have a time machine, let me know. Questions? Brain hurt? I know. I'm done early because we started class early. So go ahead and write your summary. I'll pass out homework in a second. I'll explain homework in a second. And then you're going to be able to work on last night's homework if you need to. Tonight's homework also, which is then due Monday.